Greetings to all. Myself, Uma Maheshwari, working as Assistant Professor in Kamaraj College of Engineering and Technology, Virudhunagar. Today we are going to see the demonstration on how to access VLab. VLab, that is Virtual Lab, is a project initiated by Ministry of Education, Government of India. The main objective of the program is to enhance the learning skills of a student to learn at their own pace as well as at their own convenient time. For accessing VLab, we have to open a browser and type vlab.co.in. Once again, I am repeat vlab.co.in. So the virtual lab window opens. So this is the home page. In the home page itself, they have mentioned this is an initiative of Ministry of Education under the National Mission on Education through ICT. And they have given the objective, why they have designed virtual lab, what is the purpose. So the virtual lab is designed for the benefits of student community as well as faculty community to impart technical education. And these are the some of the broad areas of virtual labs. We can see almost all the engineering branches like electronics and communication, computer science and engineering, electrical engineering, mechanical engineering, civil engineering. Almost they have covered all the engineering streams for accessing this VLab. So I am going to do some basic experiment in electronics. So I choose electronics and communication tab. Now the electronics and communication web page opens. So here they have listed the basic and fundamental lab courses related to ECE curriculum like analog electronics lab, basic electronics lab, digital electronics lab. So these are the fundamental lab courses related to ECE curriculum. The student, those who are belongs to ECE department, definitely come across these lab courses physically. So I am work with half wave rectifier, so that comes under the category of basic electronics lab. So I choose basic electronics lab. So now the basic electronics lab window opens. It's getting open. So this is the basic electronics virtual laboratory web page. Here they have listed introduction, objective, list of experiments. As a teacher, we also tell information about intro about the course, objective of a course, and we will give a course plan stating the list of experiments to the students before conducting the lab courses. So similarly, they have designed the basic informations like introduction and objective list of experiments related to the basic electronics lab. So now I select list of experiments. So here they have listed the experiments related to basic electronics lab. Totally they have designed 17 experiments. So these are all some basic experiments related to basic electronics lab like resistor, capacitor, inductors, and then VI characteristics of diode and half wave rectifications, and it goes on. So I am going to select half wave rectification tab. So the half wave rectification window is getting to open. So here also they have mentioned the aim, theory, pre-test procedures. What actually we are following in our physical lab. We will tell the students about aim of experiment, and we will tell the theory part and conduct the pre-test, or we will ask some viva questions. Likewise, they have designed the VLab what we are following in the physical lab. So this is theory part. I am clicking the theory part. So here they have mentioned what is rectification process and the circuit diagram, working principle, input output waveforms, and parameters related to half wave rectifiers. So the student has to go through all these theory content related to the half wave rectifier before starting the experiment. And then you go with pre-test. So here they have asked some basic questions. What is the ripple factor of half wave rectifier? If the student studied the theory part very well, he can answer. The correct answer is 1.21, and I submit. So immediately the result published, that is 1 out of 1. So this is the correct answer. So the next procedures in physical lab also we will tell a step by step procedure how to proceed with lab experiments. Here also they have mentioned the step by step procedures. Set the resistor value, click on button to start the experiment, click on the sine wave button. Similarly they have listed the procedure or instructions step by step. Next part is simulation. Actually, this is different from physical lab. In physical lab, the students work with real components. Here, you are doing it with simulation windows. So, in the simulation window, there are two options are available. One is half wave rectifier, another one is half wave rectifier draw circuit. So, the basic difference is in half wave rectifier, the components are available. There is no connections. Only the user should make connections related to the components based on the circuit diagram. So the user has to make a connections. Only the components like diode, sine wave generators, oscilloscope and resistor part, these are available. So user has to make a connections and proceed with experiments. Whereas in half wave rectifier, once I have clicked the options, so the circuit diagram is completely available with both components as well as connections. No need to connect, it is ready-madely available. So we have to follow the instructions what they have given. So first step is set the resistor RL. So this is RL. So I have to set the resistance value with the help of this slider. So the minimum value is 100 and maximum value is 1000 ohms. So I fix 1000 ohms. So the next step is click on the on button to start the experiments. So here there is a on button. So these control options are disabled and CRO is disabled. Once I turn on the experiment, so the oscilloscope as well as the control options are enabled. Now I will double click the sine wave. So this is the input waveform. Here in the CRO the input waveform is appeared. So what we are doing in function generator is we are adjusting the frequency and we are adjusting the amplitude. Likewise with the help of this controls we can set the amplitude as well as the frequency. So this is about input and we know the working principle of half wave rectifiers. During positive half cycle the diode conducts and hence the output appears across the RL. During negative half cycle the diode doesn't conduct and hence no output across RL. Now we can see the output waveform by clicking the oscilloscope. Now you can see the output waveform. For positive half cycle we will get output, for negative half cycle it is disappears. So the channel 1 is meant for input waveform to display the input waveform and channel 2 is meant for display the output waveform. Suppose we want to see both the input and output waveforms on the same screen, we have to click the dual option. So thereby both input waveform and output waveforms are appear on the same screen, but it is overlap. So by adjusting the channel 1 position, I can move down the input waveform or else I can move upside. So we can change the position. Similarly, we can adjust the position of channel 2 waveform. What we are doing in physical CRO. So in physical CRO, we have options of single channel, dual channel and adjustment of positions. Likewise, here also they have given provisions. And next one is calculations. So here they have mentioned the formulas and I suppose I want to calculate the average output voltage, that is VDC, which is equal to Vm by pi. I have to note the Vm value, that is 1 volt. So with the help of virtual calculators I can do the calculations. Vm 1 volt divided by pi, that is 3.14. So I will get the output DC voltage, that is 0.318 volt. Similarly, we can do other calculations. So this is about half wave rectifiers. Thank you for watching. And next video we will see about the half adder in digital lab. Thank you.